we have given a graph of the function f over here, right? And then our goal is to, by using that information of this graph over here, graph of the function f, we need to calculate this quantity over here. We need to find the limit of the function when x gets closer and closer to -3, and from the right side, right? So the right side limit at -3 we need to figure out. That's what the plus sign on the superscript represent. And then we also need to find the limit of the function f of x when x gets closer and closer to -3 from the left side, right? That's what it means by that superscript sign over there. And we also need to find the limit of the function when x gets closer and closer to -3, and the value of the function at -3. And then it says if it exists. So those are the things we need to figure out. Right, so let's try to spend time on how to find the limit of the function at -3 from the right side, or the right side limit of the function at -3. Okay, so how can we find that? So where is -3 on the x-axis? So if -2 is here, -4 is somewhere over here, -3 must be over here. So to find the right side limit at -3, what we just need to do is go closer and closer to -3 on the x-axis from the right side. But when you do that, let's try to see each time what is the height of the curve, or the y value we have. So the y values is determined by this curve over here, right? So if that is the case, this is just getting closer and closer, closer and closer to, so -3 is somewhere over here. So we still need to go, wow, it's getting closer and closer to that hole. And where is that? What is the location of that? What is the height of that location? Somewhere over here. I can say that is actually -3, right? So if that is the case, -3 is the right side limit of this function at -3. Okay, so in the similar way, can you find the limit of this function at -3 from the left side, or the left side limit of the function at -3? So what do we need to do? We just need to go closer and closer to -3 from now, actually on the x-axis from left side, and just see whenever you do that, you can see the y values is just getting closer and closer to this location, which is again here at actually -3. So if that is the case, wow, awesome. So this is actually the limit of the function, right, at -3. But what limit, what type of limit? When x gets closer and closer to -3 from the left side. How do you find the limit of the function when x gets closer and closer to -3? The limit, not the right and left. By the definition, if the right side limit exists and that is equal to the left side of the limit of the function, right, at certain location, then actually this will be, if they are same, right? So if that is the case, then that is the limit of the function. So we can just write that down, or by just, let's go closer and closer to -3 from the left and then right, and then see how the y values from the both side behaves, if they behave in the same way, and then we just figure out the limit, right? And that's the same idea, and then this is -3 again. Alright, so but how do you find the value of the function exactly at -3? To find the value of the function exactly at -3, we just need to look into what is the y value over there. So let's try to go ahead and then look into -3 somewhere over here. The height of the curve at that place, the y value is determined by this, but wow, unfortunately you can see here, here is a hole there. So that means the function is not defined, and I don't see any solid dirt nowhere on that. If you just go like along that vertical line over here corresponding to x equal to -3, I mean, I don't see any like a solid dirt there. That means actually the function is not defined there. Okay, you could either write down here undefined or does not exist, whatever name preferred, you can write that down. But I like if the function is not defined, write down undefined. Or some of the people, they also like to write down DNE, just the abbreviated form of the does not exist. So it's your choice.